Hi there, welcome back to Best Practices for Grade 4, Compose and Decompose Fractions and Mixed Numbers. I'm Bailey Murphy. I want to take a moment and I want you to look at these two photos and I want you to think about what do you notice, what do you see, and what wonderings do you have? What kind of questions come to your mind when you're looking at these two pictures? So if we look at the first picture, I see all the ingredients of a s'more, and in the second one, I see that they're all put together. So I want you to think, are these two pictures the same? If so, why are they the same? Maybe somebody thinks they're the same because they're the same ingredients. But maybe somebody else thinks that they're different because they're not all put together. So I want you to keep the s'mores and the s'more ingredients in the back of your head while we talk about composing and decomposing fractions and mixed numbers. During this 4th grade unit of composing and decomposing fractions and mixed numbers, students are going to be asked to decompose a fraction into a sum of fractions with the same denominator using concrete pictorial models and then recording it symbolically in an equation. So the 3 pictures all represent 5, 6 using different models and different equations to represent the same fraction. What does student learning look like in the classroom? In the classroom, students should be given lots of opportunities to explore using concrete tools to decompose and compose fractions of the same value. So in the first example, students are asked to decompose 5, 6, and they're asked to draw a representation of how they decomposed it, as well as writing an equation to show their representation. As students move throughout the unit, they should start to see fractions greater than 1 and mixed numbers. So in this example, students are working with the fraction 17/8, and they're being asked to decompose it as well as draw a model of it. So during the entire unit, a lot of the MTRs that you should see should be MTRs 2, 4, 5, and 6. What does student learning sound like in the classroom? Students should be able to answer a variety of questions, such as what can you determine from a fraction that has a numerator greater than its denominator? Students should be able to say that a fraction with a numerator greater than its denominator is a fraction over 1 whole, or is a fraction greater than 1. How can we decompose an improper fraction? Students should be able to use equations, models, and decompose fractions greater than 1 in multiple ways. How did you add the fractions in your number sentence? This is a great question to highlight. Decomposing and composing fractions really sets the tone for addition and subtracting of fractions, which comes later in the year. Students need to understand how they can add these fractions and understand that we're adding the numerators and the denominator where the size of the pieces stays the same. How can you develop a mixed number from an improper fraction with no model? Again, students should be able to use equations to determine how that mixed number can be written as a fraction greater than 1. Throughout this unit, there's a lot of vocabulary that students should be using when discussing mathematical ideas. They should be using the words compose, decompose, denominator, numerator, unit fractions, interval, and linear models. How will students demonstrate their knowledge? Students will be able to use concrete tools and pictorial representations to show how they are decomposing and composing fractions. Students will also be able to use equations to represent decomposing in a variety of ways. Students might be given questions such as these where they're asked to determine which of the equations matches the scenario that they've just read. And of course, students can always play games to demonstrate their knowledge and understanding of decomposing and composing fractions. In this game, students are to match the mixed number with the fraction greater than 1. Throughout the unit, there are some questions you can use to gauge student understanding. So for example, how can you explain that 4/3 is equivalent to the expression of 1/3 plus 3/3? Students should be able to build or draw a model or use equations to explain that the sum of those two fractions is equal to the amount of 4/3. The second question is kind of similar. It is asking students to explain how the expression 2/4 plus 1/4 is the same as 1/4 plus 1/4 plus 1/4 using a visual model. And also asking them to identify what fraction is the expression equivalent to. So students should be able to draw or build a model to show both of these expressions and then to represent them as the sum of those fractions. So here's an activity you can do at home to practice this skill. Students can look inside their fridge and find anything that they have a set of, such as a dozen eggs or a 6-pack of soda cans. And then students can be asked a variety of questions to show their understanding of that set of objects. So for example, I have this egg carton. I can see that there should be 10 eggs to make a whole, so this would be 10 tenths if I had my whole set. I can see that 4 of the eggs have been eaten, which means 4 tenths of my eggs are gone. Students can do this with a lot of different things, and I really encourage you to look around and find real-world connections you can make to fractions. The MTRs connected to this are 2 and 7. Thanks so much for joining us today to talk about 4th grade decomposing and composing fractions in mixed numbers. I hope you learned something, and I hope you can find a real-world connection to use your fractions just like this guy did in turning in his homework. See you next time.